All right, good morning, everyone. Welcome to the APCORE Bluetooth MIT App Inventor workshop. Today, we'll be showing you the step-by-step process of developing a Bluetooth transceiver by using the MIT App Inventor. Okay, first of all, I'm Inventor from APCORE student section. And for those new to APCORE, APCORE is a place where students from engineering and IT fields gather together and explore the world of robotics engineering. If you have been to APU campus, you are located at the lab site, level 3 lab. APCORE lab site will be nearer to the machinery side, that site. Okay, as an introduction, Bluetooth is a short-range wireless technology. It's a normal standard that is used for exchanging data between fixed and mobile devices. And the Bluetooth technology has came a long way since the early 1990s from the Bluetooth 1.0 until the current day of Bluetooth 5.0. I think by now everyone is very familiar with Bluetooth applications, from your earphones to your AirPods. Even if for ME students, your Arduino projects, you will be exposed to Bluetooth modules very often. And Bluetooth is inevitable in our lives, in our daily lives. Okay, some introduction about the MIT App Inventor. MIT App Inventor is basically an online platform designed to teach computational thinking concepts through development of mobile applications. The users can create applications by simply dragging and dropping the components into a design view and using a visual block diagram to program our application behavior. The interface is very simple with drag and drop functions. It's very similar to Autodesk, the Tinkercad. The MIT App Inventor is very useful for developing fast, simple tasks, such as an app that controls a robot or even a simple game. Alright, that's all from me. From now, I'll pass it to Chong. Thank you.
Thank you, Alvin. So now I'll be going through the hands-on for Arduino and the MIT App Inventor. So first off, I would like to introduce the Arduino AT mode. Basically, what AT mode is that it's a setting for your Bluetooth module. If you need to, for example, change the name, change the password, know about the specifications of the Bluetooth module through your serial monitor, you can always use the AT mode. So one way to set the AT mode is to, first of all, have a code like this. This code I took from the internet, but I will just share it to the chat so that everyone can view it. So this is the file. If anyone wants it, you can use it for this code to go into your AT mode. So the thing about AT mode is that we'll be using several sections of the Bluetooth module. Mainly the RX and TX, the receive and transmit of the Bluetooth, and also the enable pin, which is normally not used for normal task. So for now, I will share how do we connect that first. Just give me a moment. Okay. So the way we connect this, hold on, yeah, apologies. Now, as you can all see, this is a Bluetooth module, the HC05 module that I have with me for now. Normally on the market, you did find HC06 and HC05. Both work the same, but then it's just that their features on the outside are a little different. So the pin we would be using for AT mode would be from the left side over here, which is the enable pin, all the way to RX pin on the second rightmost. Okay, this is what we will be using. So when we connect, we will have to look at the code to connect accordingly, right? So for example, the code says this, pardon. The code says this, we should connect the RX pin to the Arduino 11 pin. Already clearly stated that. So we just connect as usual. And the pin mode 9, the pin number 9 will be connected to the enable pin of the Arduino. So let me connect it first. Right, I've connected it. So to set the AT mode, what you must do before you switch on your Arduino is to first hold down on the button that we have over in the Bluetooth module. If you guys have Bluetooth module, I'm sure that you guys would see a button over there. So for now, let me just show it again. Right. So the button will be over here. Before you connect to the power source, to go into AT mode, you have to hold down on this button and then simultaneously connect to the power source. So I will demonstrate this in a while. Right. So I've connected it. Right, since I need two hands, I'll be switching on my camera for the time being. Okay. Right, then in AT mode, you will find that the Bluetooth module will be blinking slowly. Okay, this signifies that it's in AT mode. If it is not in AT mode, it will be blinking faster. So since I already have the code uploaded to my Arduino, I can now just start it. Okay, it's in COM4. And this is the first step in signifying that the serial monitor realizes that it's in AT mode. Now for the AT commands, I have uploaded under the file section of this group. So you guys can go ahead and check it. I'll just show it just in case. You guys can go here, files, and this is the set of AT commands over here. Right, for the AT commands, it will look like this. So to test whether is it truly in AT command, we can use this function over here. So open up the serial monitor, AT, and okay. If it's okay, that means it's in AT mode. For example, if I want the name of my current Bluetooth module, I could have AT plus name that stembot1. If you want to change the name, for example, and then let's just say I would want to name it okay, then you check the name again. There we go. But since this Bluetooth module belongs to APCORE, I will change it back. I will change back the name. Right, so that's for name changing. Normally, this is the for basic use. This is what we would do. Change the name or inquire the password. You can also do that too. And the default password is 1234. You can change it if you want to by following this instructions over here. And there are tons of other instructions, but for normal usage, we normally don't use it. Unless you want more complicated functions, then yes, you did have to use it to customize your settings. Okay, so that's for AT mode. Right, so let's get into the Arduino with the MIT App Inventor. So here is my Arduino code. And normally, the things to do with Arduino is that you would need a library called software serial. So with software serial, it makes your coding with Arduino much more easier. And as you can see here, this defines the Arduino RX or T to TX and TX pin, sorry. And you did normally have to set the serial communication with Bluetooth and set the timeout. And you would normally also need this line of code such that your Bluetooth only reacts if you provide input to it. And input could be messages from your device or any other device that you intend to connect it with. And then the code down here, it's simple Arduino code. Okay, because I defined my LEDs to low and high and such, I will show you guys the connections later. And this is an example of an MIT App Inventor. To build the app is fairly simple. You first build the layout. You can position it like such. And normally, if we want to have a very nice layout, we would, for example, use something like the vertical arrangement, the table arrangement and such. I can show you guys now. I'll start a new project. Okay, and you did want to navigate to layout. So for example, I want to position 3 buttons horizontally across. I'll show you guys the without using the layouts to do so. If you don't use the layout to do so, it's very hard for you to position your buttons horizontally. And technically, it's impossible at all. Okay, so you would actually need the layout to position it very nicely. So we have 3 columns. I want 3 columns, and I only want 1 row. And as you can see here, I could place the buttons neatly like that. Okay, and then it would automatically adjust its size based on your buttons. So for example, if I rename my buttons, let's just say I rename it okay, button 1. That it would automatically reposition itself and resize itself also. So what happens if we want to do it very nicely? That means we want it to be of equal width and such. Okay, so we could actually use the percent. For 100%, it would mean that the width would go from here to here, technically from the edge of the phone to the other edge of the phone. Okay, hold on. Right, so that's for columns. But then as you can see, the buttons now are still tightly packed inside. So you will have to make some adjustments. One way to do so is to add more columns. For example, I can add 5 columns. You can position it as such. But it normally works for smaller buttons if you do this method. Wouldn't work so well with the buttons I have right now. So let's try another method of doing so. Another method of doing so is that you don't need so much columns. For example, I just use 3. Oops. Okay, now I have 3 buttons. And what you want to do is look for a layout. We just move this out here first. Hold on. Yeah. So we can put the container. Let's just put everything in my container for now. You could normally have a container like that. And then the height, I would want a 100%. Okay, let's make a container for now. And then since we have 3 buttons over here, if we were to calculate the width of the entire thing, three would be 33.3%. So we can scale our buttons to 33.3% width. Okay, I suddenly forgot that MIT App Inventor does not allow for that, sorry. Hold on. I think it's better if I show you guys this, which I already did. So sorry for that, because I am technically speaking, I am a casual user of MIT App Inventor. So sorry for the inconvenience. So for example, you can have something like that. I made the 3 columns over here for table arrangement. Just to prove it to you guys, this is my table arrangement. And then what I did was that I sized all of my buttons and stuff here to 3.3%. That's how I did it. And as for my rows, I put 6 rows, and the rows would automatically adjust itself, so there's no worries. You would want to pay more attention to the width, because your width is the smaller portion of your phone. So it's best to pay more attention to that. And for the rows, you generally don't have to, because you have quite a lot of space. And even if you exceed it, you could always just put a scroller there. But since we won't be exceeding any of those for now, we won't need that. Okay, so let's go on with the blocks. So here is the programming part. If you just design the layout here without doing anything to the blocks, your app is technically useless because it won't really work. So for now, I'll just go through the Bluetooth first. The Bluetooth we will actually be using is the Bluetooth client. You can just find it over here. And to use the Bluetooth, you must have it inside your app layout. So you can just drag it and put it here. And it will be there. You will also need a clock. The clock is something like the Arduino, the void loop. It will just keep asking for a connection. So these are the Bluetooth elements, both of this, and this is the clock element. So let's go through the Bluetooth element first. So before we do anything, okay, this is when connect. Connect is this speaker, which is a type of button that when you press, it will show out a list. So before I connect anything, before I select the list picker, okay, I want to connect the elements inside the list picker to the addresses and names the Bluetooth client detects. Okay, so after I click on the list picker, I will want to call the Bluetooth client and connect and refer it to the connect button and put it under the selections. Okay, so after that, wait, sorry, I got confused there for a moment. Right, so after we select the list picker, so we'll have to call the Bluetooth client and we will want to connect the address to selection. And if it's successful, okay, it will just set the connect elements to the Bluetooth client addresses and names. Right, so let me show you how that looks like. Right, so to develop your app, you can always use the app companion app you have. You can download it from Google Play Store. Okay, it's connected. So for example, I press the connect button, there it will show. This is what it looks like. Okay, this 2 blocks of code actually lead to this. And after that, I can just connect it however I want. But we'll do that later. And as always, if we have a connect button, we will also need the disconnect button. So what happens if we press on the disconnect button is that we will call the Bluetooth client to send the text off. We will need that later for the Arduino. But technically, most probably you only need this if you don't want to display anything. So I'll put this back here first. Okay, and this is what the buttons would do. So when I click on red, I want it to send the text red. When I click on green, I want it to send the text green, and so on and so forth. Now it's for the clock. So for the clock, I will dissect it out first. So in this app I developed, okay, first of all, we will have to detect if the Bluetooth client is connected or not. So once it's connected, I would like to set the connect this speaker button. This speaker is this. Okay, I want to set it to blue color if it's connected. Otherwise, if it's not connected, then I will want to set it back to gray. And this line of code is actually to receive messages. So where would we be receiving the messages? It will actually be in this text label tree over here. This is where we would receive the messages that is sent from the serial monitor. And this is actually much needed if we were to receive messages from our serial monitor. Otherwise, you would receive the messages once and then it will disappear. So if I use this, the message won't disappear. Why is that so? Because this tells the app to only receive your messages when the byte sent from your serial monitor is more than 0. And in this case, if we send anything that has content, like for example, a letter T, the byte will always be more than 1. Sorry, will always be more than 0. So that is why we set it as such. Okay? And then if it receives something useful, I would want to set the label text, the label tree, which is this section over here, to the number of bytes the Bluetooth client receives, which is our messages. Okay, so for now, I would have to show you guys how I connect the LEDs and such. So since I have very limited components with me, the most I can show you is with LEDs. Okay, so what I have on hand is actually a 220 ohms resistance, and the green and the red LED, simple stuff. And then I will be using the number 8 pin to connect to the red, number 9 pin to connect, number 9 pin to connect to the green, and the ground would be actually shared between the 2 LEDs. Right? Hold on, I see some messages. Yap Sen Long. If we are talking about the MIT App Inventor, it would export it into APK. But if it's still under development, and then you would want to build it or share it, you could always publish it as an AIA file. Hold on. Yeah, you can import the project as an AIA file into your computer, and then you can share it with others so that they can help you develop the app. But in any case, if you feel like you have finished building it, you could always just save the app as APK into your computer. Does that answer your question? Yeah, you can scan the QR code. Depends on which method you prefer. Either way is fine as long as you get the APK app and it works. Okay, so where was I? Right, back to the circuit design. Okay, this is for the breadboard to Arduino connection. Since Tinkercad does not offer me the HC05 module, you guys can search for it if you are using Tinkercad. The HC05 module won't be anywhere inside here. So I will have to actually show it to you in real life. Just give me a moment to reconnect my stuff. Okay, I'm not so sure with iPhone because I don't use iPhone. I'm using Android. Due to the flexibility, I would always prefer Android. Okay, so now I finished connected my Bluetooth module. I hooked it up together. Let me show you guys how a Bluetooth module would be normally hooked up with wires and such. Right, so here is normally how it's going to be hooked up. Please be mindful to not use the enable pin because we are not configuring for AT mode. Okay, so it's just for basic usage, only this 4 pin will be used. Right? So let's go back to the code I prepared. I believe it would be best if I share the code to you guys also. Right, so that's for the code that I prepared. And as we can see here, for the Bluetooth connection, I would need the 12 and 13 pin on the Arduino. And it says Arduino RX. That means I would be using the receive for Arduino pin 12. And if I use receive for Arduino pin 12, that means my Bluetooth module TX transmit would have to go to pin 12. Okay. Arduino transmit to pin 12. Sorry, Bluetooth module transmit to pin 12. And then for the Arduino TX, I assigned it to pin 13. So my Bluetooth module RX would have to go towards 13. Okay, and then now I would connect my ground and my 5-volt power connection. Okay, so that's all you need. So I'll show you guys the connection again. So this is normally how it looks like on the breadboard. Sorry, not on the breadboard. On direct connection of Bluetooth module to the Arduino. Okay, so no breadboard needed. If you want to use it on the breadboard because you don't have wires, you could. But in any case, I would really recommend that you have this sort of female to male jumpers. If you only have male to male jumpers, then you would have to connect it like how I did just now which might be a little messy, so you need to watch yourself there. Okay. So now for the connection of the circuit, I think I can just show you guys how I connect in the meanwhile, since only one hand is needed. So this is my red LED. And if you look at the code, I define my red LED as pin number 8. So I go to pin number 8. Okay, sorry. Yeah, now you guys can see. Pin number 8 is over here. And my red LED is connected to this. Right? And then afterwards, my green LED is connected to number 9. Right, my green is here to number 9. Okay, and this one will be connected to ground. I just need to borrow any ground over here in the Arduino. Okay, it might look a little bit messy, but it stays true to the Tinkercad that I built. Okay, so now let's test the code. Let's test if it works. So I'll have to reconnect again with the AI companion. Okay, so I would be connecting my Arduino, give it power. So if you guys have connected the Bluetooth module normally, it would be blinking very fast like that, contrary to the AT mode just now. So let's go back to our app there. Right, so let me upload the code first. Okay, so finish uploading. Now I will switch on my serial monitor. Okay. So as you guys can remember, we call it to send a text right over there, right? And then in my code here, I also call it to print out whatever messages it received. Okay, so I believe I am not going into the Arduino code for the Bluetooth section over here first. So what it says here is that if the Bluetooth module receives some useful message, that means the byte is more than 1. And then I would want to set it as a string message. Normally we would use string because string is much more easier to send. If you want to send by bytes, you could, but it will be much more harder because it is a rather asynchronous type of message. So you would actually depend heavily on timing. And if you mess up the timing, your message that you receive is going to be very weird. So for this reason, normally you would use string, unless you really have to use the bytes, send by bytes, then there's not really much you can do. But Preferably string is much more better. Okay, and then I will want to print the message out. So that's all. So for example, if I click on red, oh sorry, I'm not connected to Bluetooth. Yes. Okay, that's weird. Hold on, it's technical issues. Let me just pair my device again. Okay, so if your device is paired is enough, it doesn't have to connect. Okay, so let's go back to my app, and I would believe that I have to scan the app again. Okay, so I believe now I could connect it already. Oh, okay. Right. Now it's connected. And so I will have to put this over here, and I'll put this over here. Okay, so here's my serial monitor, and there's the controller here. So you won't be able to see the what's happening on the breadboard now because I'm showing this, but I'll show you guys later. So for example, if I press the red, I want the red LED to shine. Press red. Yeah, I accidentally double click on that just now. So that's why it shows 2 times. Green, off. And if I want both to shine, off. Okay, so if I disconnect, it will show off first, then it will shut off. So that's how you would normally do it. And then I want to connect back again. There, it's connected again. And then I could redo everything again. And if I want to send message, okay, it does not work for the HC05 module, but then I will show you guys the send message later. Right, so now I will show you guys what's actually happening on the breadboard. So I just switch off everything first, disconnect. Okay, I believe that I would have to improvise a little. Okay. Right, pardon for the lack of cameras here. Just let me. Okay. I believe that you guys can see it clearly now. So what happens on the breadboard is this. For example, I want the red button to shine. Sorry, red LED to shine. Press red. Oh, sorry. Got to connect again. Okay, I press red. Then it shines. And then I press green. Shines again. And depending on the value of resistance you have and the specifications of the LED itself, the brightness may vary. So I'm using a fairly low resistance right now. It's just 220 ohms. So that is why you can see noticeable brightness. And then if I want both to shine, press on. It's red and green at the same time. Then I press off again. Just switch off both. Okay. And then if I press disconnect, nothing really happens. So that's that for the Bluetooth connection. And I understand that if you guys, some of you guys here don't really have any, how to say, the Bluetooth module and such. So now I'll show you how you could connect your MIT App Inventor with your serial monitor directly. That means it's going to be communicating between your phone and it's going to be communicating, it's going to be communicating between your phone and your PC. So first off, what you need to do is, of course, you connect your, okay, you connect your, you pair your you pair your phone. You have to pair your phone. You have to switch on all of your Bluetooth and such. Okay, and you would not need any Arduino at all. No Arduino needed, just your phone and just your PC should be enough. And what you want to do is you want to go to your Bluetooth settings over here. Primarily this. You want to set your COM port. Okay, I just show as an example. I remove this first. You want to add a COM port. It won't show anything incoming, so you just ignore that. Press OK. And then it will set the COM port for you. This is important because it allows your computer to it allows your computer to send messages back into your MIT App Inventor also, and your MIT App Inventor into your PC. Okay? So once you have that, just OK. And then we would need a serial monitor online. Any type of serial monitor would do, but since we have the Arduino serial monitor, we will just use it, right? And if you just click on the serial monitor like that, it will show COM4 not available. So you will have to actually go to COM5, serial monitor. You don't have to matter the code over here. If the code over here is not the same as the code just now I gave, doesn't really matter. Can even be blank. Okay, so I would connect this time with my desktop. Okay, connected. Good. And if I press red, it will show red. Press green, show green. And since I didn't put a backslash and just now in the MIT App Inventor, so everything's all clumped up like that. But then that's fine. As long as it's showing something, that means it's good. Off, and it's off. All, disconnect, off. And you could connect back again, no worries. And then you want to send messages also can. Yeah, see? Then you want to send a very long message also can. So there's that for the Bluetooth. Does anyone have any questions? No questions? Okay, does anyone have any questions regarding the MIT App Inventor and such? Like which part of the code you guys don't understand, or which part of the Arduino code you guys don't understand? I'm happy to explain. Okay, no, it seems like everyone's fine with that. Yeah, okay. So if you guys don't have any other questions, I believe that is all I have to show. I have the code there given just now. You guys could mess around with the code. All you need is your phone and all you need is your PC. Mess around with both the code. Hold on, I'll share the AIA file also. Oops. Right, I exported it. Okay, so the way to use this AIA file, I'll show you guys with the MIT App Inventor. Just go to projects, import from your PC if you downloaded it, choose file, just choose the file. Yeah, since I have the same one, I cannot do anything. But then if it's something different, then yeah, you could actually just load the file here and start developing the app. Okay, this is just a very basic example. Okay, so that's all I have for now. Alvin, do you have anything to add on? Oh, Alvin does not have anything to add on. Okay, so since we have basically finished discussing what we have to discuss and I have shown you everything I could, I believe that is the end of the workshop. So thank you everyone for attending. But first, before we end, I think it would be best if we took a picture together. So please switch on your cameras. Okay, we need more people. Switch on the cameras. Okay. Let's wait one more minute. Alvin, do you want to do the honors of taking the picture?
Okay, sure.
Okay.
3, 2, 1. Wait, one more. Okay, 3, 2, 1. All right. Okay, that's all.
All right. Thank you everyone for joining this session. And hope everyone has a wonderful day ahead. That's it for now. Right, thank you. You're welcome.